Imagine standing at the edge of everything. Behind you, all of creation. Every star, every galaxy, every atom of your body. Ahead of you, nothing. Or is it? For centuries, humanity has gazed at the night sky and wondered, does the universe end? And if it does, what's beyond the edge? Today, we're venturing to the absolute boundary of existence itself. What we discover will shatter everything you thought you knew about reality. Let's start with something that sounds simple but is actually very tricky. When scientists talk about the edge of the universe, they're usually not talking about a wall, a border, or a cliff in space. They're talking about the edge of what we can see right now. We can detect galaxies up to about 46 billion light-years away in every direction. That entire sphere around us is called the observable universe. It's like a giant bubble with us in the middle. Not because we're special, but because we're the ones doing the observing. This bubble is about 92 billion light-years across. But the universe itself? It might be much bigger, maybe infinite. The edge we talk about is really just the edge of our vision, not the edge of reality. So what's the difference between the observable universe and the entire universe? Think of standing in a foggy field at night with a flashlight. The circle of light around you is your observable field. You can only see what the light reaches. But the actual field might stretch far beyond what you can see. The observable universe is like that circle of light. The observable universe is everything from which light has had time to reach us since the Big Bang. The entire universe is everything that exists, including the parts whose light hasn't reached us yet. Light has a finite speed. The universe has a finite age. Put those together, and you get a horizon beyond which we can't see, at least not yet. The universe beyond that horizon is hidden, not because it doesn't exist, but because the laws of physics won't let its light reach us in time. Here's where it gets wild. The universe isn't just sitting still, space itself is expanding. A classic analogy is a raisin-bread dough. Imagine raisins as galaxies and the dough as space. As the dough rises and expands, every raisin moves away from every other raisin. There's no single center where the expansion starts from, and no raisin is at the edge of the dough. From the point of view of any galaxy, it looks like everything else is moving away. This expansion is described by something called Hubble's law. The farther away a galaxy is, the faster it appears to be moving away from us. It's not because the galaxies are zooming through space like rockets. It's because more space is being created between them. And over huge distances, that expansion can make galaxies recede from us faster than the speed of light. That might sound like it breaks physics, but it doesn't, because they are not moving through space faster than light. Space itself is stretching. Even stranger, this expansion is accelerating, driven by something we call dark energy. We don't really know what dark energy is. We just know it's pushing the universe apart faster and faster. Now, let's talk about our cosmic horizon. The universe is about 13.8 billion years old. Light has had 13.8 billion years to travel. But because space has expanded while light was on the way, the objects that emitted that light are now much farther away, tens of billions of light years. The most distant thing we can see is the cosmic microwave background, the afterglow of the Big Bang, released when the universe was just about 380,000 years old. Before that time, the universe was so hot and dense that light couldn't travel freely. That glowing shell of ancient light forms a kind of surface around us. It's not a physical shell we could hit, it's a limit in time. We're seeing the universe as it was in its baby picture. Beyond that, there's more universe. We just can't see it because no light from there has reached us yet. This limit, the farthest distance from which light can reach us, is called our cosmic horizon. It's the real edge, in the sense of what we can currently observe. So does the universe have a physical edge, like the end of a road? All evidence so far says no. If the universe is infinite, then it simply doesn't end. You can keep going in any direction forever and never hit a wall. Even if the universe is finite, it may still have no edge. Think about the surface of Earth. If you walk in a straight line long enough, you'll eventually return to where you started. You never fall off an edge because there isn't one. The surface is finite but unbounded. Space might be like that in 3 dimensions. It could curve back on itself in ways our brains find hard to picture. You could travel in what feels like a straight line and eventually end up back where you started, without ever encountering a wall. So when people imagine a spaceship flying to the edge of the universe and looking over into nothingness, that picture almost certainly isn't how reality works. Now for the big question: what lies beyond our observable universe? Possibility 1. More of the same. Most cosmologists think the universe beyond our horizon probably looks a lot like the part we can see. Galaxies, clusters, cosmic structures stretching on and on. If the universe is infinite, then beyond our observable patch is just an endless continuation of space, with more galaxies and maybe other regions where conditions are slightly different. Possibility 2. Cosmic curvature or strange topology. The universe might wrap around on itself in a complex shape, like a higher dimensional donut or sphere. That would mean what's beyond might actually connect back to us in a way we can't directly notice yet. Possibility 3. Other universes. And this is where things get truly mind-bending. Shortly after the Big Bang, the universe is thought to have gone through a brief period called cosmic inflation, a phase where space expanded unimaginably fast. Some theories say inflation never completely stopped. Instead, it ended in our region, creating our universe, but continued in other regions. This idea is called eternal inflation. In eternal inflation, different regions of this inflating space stop inflating at different times, forming bubble universes. Each bubble could be a separate universe with its own laws of physics, its own versions of matter and energy, maybe even its own dimensions. Our observable universe would be just one bubble in a vast multiverse. Some bubbles might be sterile, with no stars or galaxies. Others might have wildly different physical constants. A few might be similar to ours. Another idea is the many worlds interpretation of quantum mechanics, which suggests that every quantum event with multiple possible outcomes creates new branches of reality, new worlds where each outcome happens. That's a different kind of multiverse, one built from quantum possibilities rather than cosmic bubbles. None of these multiverse ideas are confirmed. They're at the frontier of physics. Speculative, fascinating, and very hard to test, but they show how far the idea of an edge has evolved. Instead of a simple wall in space, we now talk about horizons, inflating space, and whole families of universes. So, what happens at the edge of the universe? Maybe nothing special. There may be no sharp edge at all, just more space, more time, more reality than we can ever see. The only true edge we know is the edge of our knowledge, our cosmic horizon. Thousands of years ago, people thought there might be an edge to the world. They imagined ships falling off the side of a flat Earth into the void. Today, we smile at that idea. Now we stand at a much bigger shoreline, the edge of the observable universe. Beyond it lies something we can't see, can't visit, and maybe can't ever fully understand. But that mystery is not a dead end. It's an invitation. Every new telescope, every new theory, every new observation pushes our horizon a little farther back. We learn more about the first moments after the Big Bang, about dark energy, about the geometry of space, and maybe one day, about other universes. The edge of the universe isn't a place you can travel to. It's a moving boundary between what we know and what we don't know yet. And that means the real question isn't, where does the universe end? The real question is, how far are we willing to go to find out? If this journey to the edge of existence sparked your curiosity, let's keep exploring together. What do you think lies beyond our observable universe? Drop your theories in the comments, and if you want more deep dives into the mysteries of reality, make sure to subscribe. The universe is bigger, stranger, and more beautiful than we can imagine. And this is only the beginning.